Good evening, Mark Smith, Director of Curriculum Instruction and Assessment for Monomoy. I've been tasked to speak to our recommendation at the elementary level regarding science instruction and Spanish instruction. Each of the principals are here to answer any specific questions that you have relative to their buildings, but after some discussion, we decided that one clear voice working through a presentation was the best way to go. As was mentioned a little earlier, some feedback has been received around since Dr. Carpenter's first presentation around this idea the last school committee meeting. One was the community forum that was already talked about earlier, in which, generally speaking, there were a lot of voices of the school committee members that were there, and the superintendent heard favoring Spanish. Separately, there were emails that were received from school committee members and the superintendent that supported the switch to science. So therefore, we wanted to make sure we had a broad audience in which we sent, so therefore we decided to send a survey out to families. We did focus on the elementary families. This is the group that we, the impact that is impacted most directly. And I know it was spoken to earlier that that the email wasn't received by everybody. I was just quickly, we pulled up the statistics, and I mean, from our end, 1,097 emails were delivered, and the only ones that weren't delivered were those to people who either do not have an email address on file with us, or our email address is blocked on their end. So I would encourage those people to check their spam, make sure it's coming from me. If they would like the survey directly, they can email me directly, and I can send them the link. It's just msmith@monomoy, so people are encouraged to do that. So given where we stand right now, this is as of about 5 o'clock tonight, we had 223 families respond. You can see it's close to a 50-50 split, with definitely a 6% leaning towards retaining the Spanish in the program, or the Spanish program as it is. So that is where the results stand currently. And then, so I sort of was thinking about how do I then segue into the presentation. It was a comfortable segue, and I really couldn't come up with one, so I just figured this is how we would segue. So when we talk about our recommendation to make an adjustment to the elementary program to shift away from a Spanish special and include a science, it's driven by three main factors, which I'm going to use to sort of shape the rest of the presentation. We looked at three different things. First was an evaluation of the structure of our current K-12 foreign language program. It's important, and it's emphasized and underlined. We're talking about the structure. We're not talking about the people. We're talking about the structure in which we are asking people to operate and to deliver a foreign language program to our students, and how well that structure is set up for oral language proficiency. Second was to evaluate our science content instruction at the elementary level. And then lastly was to look at our strategic planning objectives and how that all plays together to support or to drive this particular recommendation. So looking at oral proficiency. So we did some looking at the requirements for oral language proficiency. So the Ohio Department of Education did a study based upon a lot of information that comes out of the American Council on the teaching of foreign language. And you can see on the graph on the right, I know it's going to show up small, it's hard to read, but this is different levels of proficiency. The bottom is a novice, all the way up to the top level, which is distinguished. The lower levels, comparatively, advanced, intermediate, and novice, have sort of a high, medium, and low range within them as well. This is all, again, by the American Council on Teaching of Foreign Language. So in order to reach the high level of novice, so the highest, sort of be successful in the novice category, requires, according to the research, between 270 and 300 hours of language instruction. This is around oral proficiency. And novice, I just pulled out what the little blue box says over there, so that we're all working off of a common definition, again, according to the ACTFL. Novice is someone who can communicate with formulaic and rote utterances, lists, and phrases. So that's what they mean when they say novice. So then we want to take a look at the structure in which we operate, sort of thinking about those hours and minutes. So at the elementary school, we offer Spanish 45 minutes a week, which tabulates out to 620 minutes a year. And then do some math, divide by 60 minutes, you get 27 hours a year. A K-4 experience for a student who has Spanish throughout their entire K-4 experience gets 135 hours of instruction. When we move to the middle school, the model shifts a little bit. Students have foreign language for 90 days, and they alternate between the Spanish and Latin. So you're looking at 45 days of actual instruction because of the every other day piece. And so you get 48, and the blocks are obviously a little bit different, so it's a 48-minute block at the middle school. That's 45 days, 160 minutes per year, divided by 60, you get 36 hours per year. So from 5th through 7th grade, you get 108 hours of Spanish and 108 hours of Latin. So for your grand totals, you get 243 hours for K-7 Spanish and 108 hours for 5 through 7 Latin. And reminding, the lower end of the proficiency is 270 hours. Now there's also some underlying assumptions when they talk, if I just bump back a slide, when they talk about these, there's also underlying assumptions that it's a continuous program, and that it makes up anywhere between 5 and 20% of the school day. So that on a daily basis, kids are getting somewhere between 16, between 16 and a half minutes to 66 minutes, that would be the 5% to the 20% of the school day is language instruction every day. So that's sort of the assumption that these hours are built on as well. Now, when we move into the high school, the structure changes. Students are in a foreign language block as a block, and so that's part of the regular schedule. It's a year-long course. I don't know how familiar everybody is with the high school schedule, but it does rotate, so it does drop blocks. So in a 7-day cycle, kids have any of their classes 5 times, as long as they're the full year ones. But so for foreign language falls in that category. In 7 days, they have that particular foreign language 5 times. And so it's a 65-minute block, so 65 minutes times 5. And then I looked at, or times 5 gives you 320 minutes every 7 days. So then you have to look at how many 7-day blocks are there in a school year. And you get a grand total of 138 hours per year. Now, when you run the numbers out further on the scale back on the American Council on Teaching Foreign Language, you can see that in the program design the way it is at the high school, continuous, daily, and the right amount of hours, that kids can advance up into that advanced level on that upside down triangle that we showed, because the model is set up to support that. It's a structure that is supportive of learning a language to a higher level. So, and then there's other pieces that also go on. There's the language lab at the high school. They bring in, this is just sort of to explain, and none of this we're talking about changing. The kids will continue to have a well-rounded world language experience at the high school. One challenge the high school does face is that only about 50%, I think it's right now, it's dead on at 50%, right, Bill? Yeah, dead on 50% of the 8th graders have opted to take a foreign language. So you have a break there for half of the kids. And that part of that's because of the way the elective schedule, the 8th graders don't have as much freedom in their schedule. They have to make a choice, and about 50% of them, or 50% of them this year, chose not to take a foreign language. And that's pretty consistent so far for Monomoy High School. And then there are further just sort of talking about the bonuses of an immersion program. There's a lot of other great opportunities that happen at the high school that expand not only language opportunities, but also cultural opportunities. This is really just sort of pumping up some of the great things that we're doing as well at the high school. I know some people are concerned about some of the feedback that we've heard as kids won't have enough cultural exposure if we don't have Spanish in the elementary schools. This is just understanding that there are a lot of different ways that we get at cultural proficiency with students. And this is just lets you know, or lets you see how the program is designed at the high school for the courses that are offered. And you can see even in courses where we don't offer, so we don't have French K to 7, we don't have Mandarin K to 7, we only have Latin 5 through 7, we still offer the same program. And in recent years, we've only had one student who has taken the national proficiency exam, been able to move into a level other than level 1, and it was in Latin. And again, it's not about the people, it's about the structure, the amount of the time that we give to it. Now, if we think about, so this is sort of shifting to the next piece, now looking at science instruction. Why do we need more time for science? So you pulled right out of the standards, I'm not going to read the slide to you, but the recommendations in the science and technology and engineering frameworks calls for 25 minutes a day, approximately 2 hours a week for K to 2 students, and 35 minutes a day, approximately 3 hours a week for 3 to 5 students. And we're currently not hitting that number. In some places, pretty woefully hitting that number. Now, we can't have a conversation about standards without having a conversation about the elementary school teacher and what we actually ask an elementary school teacher to do today in 2019. We ask, we being everybody, we and the we's above us that give us the standards and the frameworks that we have to follow. We expect our elementary teachers to be not only content experts in math, in science, in the development of reading, from foundational reading skills, decoding, all the way up to interpreting text and making meaning, to writing, not only to fundamental encoding, but to actually expressing ideas in a coherent way. Those are two very different things. To be experts in social studies and history, to develop civic engagement in our kids, and that's the content. We ask them to also be experts in diverse learners. Our students who are learning English for the first time, our students who have neurological, cognitive, learning disabilities. We ask them to be, I guess, mini therapists in a way. There's a lot of therapeutic and social emotional learning. Students that are coming to us with more and more trauma experiences. Elementary teachers are dealing with all of this. Plus, I could probably sit here and talk more. Think about just right now, we ask them to integrate technology into their instruction. I mean, the list goes on and on and on. There's only so many ways, and you guys will start to learn, I love analogies. There's only so many ways you can split a pie and actually expect to have something left. And I'm an elementary trained teacher. That's what I did before I moved into administration. I was a K-8 principal, and my last job before coming here was I was a pre-K2 principal. I've seen this. When you're an elementary trained teacher, you're not a content expert. You're a generalist by trade. You might spend time learning a particular piece and getting really good at a particular area, but you're not a content expert by background. And for a while, that was, I don't know, the structure wasn't set up in a way that expected you to be a content expert. Now, when you read the standards and you dive into the standards, there's a content expertise in the standards that we haven't prepared people for. And again, we wouldn't ask the physics teacher at the high school to be proficient in the math standards, in the reading standards, in the social studies standards, but we do it at the elementary level. And so we have to address that. And science is, again, I was an elementary trained teacher. I took one science course. It was because it was a prerequisite in the college that I transferred. I went to 4Cs for my first year, then I went to Stonehill. 4Cs had a science prerequisite. Stonehill, where I got my education degree, did not. I could have gone through without having to take a science course. And yet, the expectation, and that experience isn't different for really many other elementary school training teachers. Now, the question has also come up around the specific standards. Just give me a second. The question has been raised, well, can't we cover the science standards in our technology courses? And it's really misleading because it is called the Science and Technology and Engineering Curriculum Framework. However, and I'm going to pick this apart a little bit more, you'll see if you look, there's also the Digital Literacy and Computer Science Curriculum Framework. Those are two different frameworks for which we are responsible in educating children. The second one is the one that most of us think of when we think technology class. But we hear science and technology engineering, we think, oh, it's like computers and stuff. But if you pull, these are the vision statements from the two frameworks, or parts of, they're multiple pages. State can't do anything short. But you can pull the main ideas here. And you can see in the first one, I've highlighted some key phrases. In the Science and Technology and Engineering framework, they're focused on science and engineering. And the technology part comes in because they want people to be consumers of scientific and technological information. The idea here is ultimately, by the time you graduate a 12th grader, you want somebody who can go to a town meeting, hear about a wastewater treatment plan, understand the science behind it and why it might be important, and make an educated vote. That's what they mean by technological information, which is different than the second framework. The second framework works specifically, you see the highlighted pieces on digital literacy, so how to be a good citizen, how to communicate and collaborate over a digital platform, and computer science, like the coding, actually how you make computers work. Those are the two drivers in that particular framework. So I'm going to drill into that a little bit more. So the science standards are organized into four major categories. You can see there: Earth and Space Science, Life, Physical, and Technology and Engineering. And they have substandards underneath them. So it gets to be a pretty dense document. I just gave an example for, and this is sort of making this point about the expertise we're expecting of elementary teachers. And this is just one sliver of what we're asking them to be an expert in. Try not to lose sight of that. So, and this further articulates the idea. So the technology and engineering standards, you can see here, if you read this, it's not about working with an iPad. It's not about using Google Docs. It's about engineer design, understanding about failure points, designing a controlled experiment. And the physical science is another example. This is one that I just so happen to know from recent conversations with the fourth grade teachers that they're struggling to understand how to teach this because it's a really complex scientific idea. It's not easy to understand about light and refraction and how that goes through the eye. I mean, how many of us could do that right now? Can you answer that? It's very difficult and complex stuff. And yet, we're just expecting that we can just do it. Now, when we break into the digital literacy and computer science standards, they're organized a little bit different. They're done in grade span, so it's like a K-2 framework and a 3-5 framework. So the 3-5 framework, where the science ones are by grade level, there are all of these different topic areas that are asked to be covered. Each one has a number of substandards underneath it. So you get 62 standards that are being asked to be covered in a 3-year span. Again, a really big task. And most of this is currently being covered in that other special, that technology piece. I know once they move into the 5th grade, there's separate courses, but there's also an integration piece of this into our science instruction back in the classroom as well. And then just again, to pull out, just try to show the difference between science and what our technology classes are trying to address. These are some of those specifics. So again, if I just toggle back real quick, you can see algorithms is up here. I already forgot which ones are the ones I use. Computing devices. These are some of those topics. And under each there are standards. So these are some of the select ones that I just pulled to show you the range. But you can see they're not about science as much as they're about either how a computer works, how you use a technological device to collaborate with others, There's a piece about using an algorithm in order to solve a problem. This is getting into coding. So we're not just having a conversation about swapping the 45 minutes for the 45 minutes. That, like from my standpoint, I would be, yeah, that's silly. You're taking one little amount of time and trading it for another little amount of time. What we are proposing and what we've included in our vision for the strategic plan, or as we try to actualize the strategic plan, is a coordinated approach. So we currently have a library class, which we are in the process, and like some places are, between the two elementaries, they're in different stages, but both moving in the same direction towards a more integrated media-based and library-based model. Including the science teacher and the technology teacher, we would have those 3 courses working in an integrated STEM fashion, supporting the classroom. I'll get into that in a little bit of it in a second. But that these 3 different positions, which 2 of them already exist, and the 3rd one is the one that we're talking about making the change, is an integrated science, technology, engineering, and math approach, where these standards are getting covered across multiple classrooms and looking for places where these standards commingle, and we can develop a nice hands-on approach. The best model of it, in my opinion, is what is going on currently, or the best visual example of it is what is already going on at the middle school, where there's science-based instruction going on in the classrooms, and then there's 2 other classes that the kids are going to that are more on the engineering focus, but it's all, what's the word I'm looking for? It's all works together. And it's reflected in the scores. If you break down the science scores at the middle school, it's the percentage of students that are in advanced and proficient this current year are 18 percentage points above the state. That's a big gap in the right direction. And we want to develop, provide opportunities for those people to work together and co-plan, to develop experiential learning activities for kids. These are the parts that fall apart for a classroom teacher, thinking about having to set up a lab experiment for kids when I also have to get to math, reading, writing, history, and I have to somehow pull all these materials together, come up with something engaging that's also going to be learning focused. It's a lot, again, when we shift back to the expectations that we're asking one person to do all these different things. And having a specialist in the building, somebody who knows this elementary science information, then allows for support back in the classroom. Lessons that can support what's going to happen in the special, and things that can happen afterwards. And you have somebody to go to that is your science expert. And then if we look at it from the numbers game, so if we're integrating these 3 classrooms and they're all working towards the same piece, you're looking at 157 minutes a week, which is taking the 45 minutes from each of them plus adding the little bit of science that we are getting in at the elementary levels as just a base. So it gives you 2.6 hours a week times 36 weeks, 94.2 hours a year. And in a K4 experience, that's 471 hours of STEM. So, because I could see the argument, right? Well, how are kids going to be any more proficient in science if you're only giving them 45 minutes, if you're making this argument that 45 minutes is Spanish? Because it's an integrated piece, you get more bang for your buck. We don't have an integrated Spanish program. And you can fault us for that, but that's just the reality that we operate inside of. So, and then the next steps beyond that would be for those people to work to support more and more work being done back in the classroom as their expertise is able to, and it's sort of like a coaching and professional development supportive model. So then the last part of this conversation is, or the last, when I listed the 3 drivers, is the strategic plan. So all I really did for this is just to pull up the strategic plan, which, to remind everybody, was started on that Saturday, the 29th, I think, in September, here in the cafeteria, and then there was a group of parents, school committee members, school personnel that helped shape that plan, and this is what the strategic plan, that group, set forth for us as a task, as an action item. And this is our proposal for how to address that particular action item.